Hi everyone. I'm Charles from North Korean Security. I'm a penetration tester and a trainer. And I've kind of brought a talk to you today on about infrastructure as a code, how we can manage it, how it's changed over the years, and a few issues around some of the key products that are out there to manage said infrastructure as a code. But first of all, we need to establish what environments are in organizations. We're all aware when we're kind of in and out, we have the three kind of key ones. We have development, pre-production, and production. And they all come in a variety of different risks, information use, data use, and they all need to be taken in consideration when creating these environments. So, for example, development are quite often just spun up for the likes of, as it does what it says on the tin, to develop pieces of software, to develop infrastructure. You're very much there to try and have an understanding of what you're trying to achieve when developing your overarching infrastructure. Then we have pre-production, which is kind of that middle gap in between that full deployment, that fully running service when it comes to the infrastructure that you are using. And this is more when it's going to have maybe replica data. We're going to start to see traffic flows occurring to be the same as if it was to be in a true production environment. Then we have the likes of your final piece, your production environment. This is very much where customer data will flow in and out. You've got the kind of correct service lines being given out, and the risk is a lot higher if it goes down, being the key factor for this particular point of production. It's that concern that it's going to fall. It's that concern that to get it back up and running to that continuity level that you're looking for that business line is going to take days. It's going to cost so much time, so much manpower, and so on. Whilst if someone to turn around and see yourselves and say the development environment is going to fall, okay, great, we'll just spin it back up another time. We'll go from there. And then pre-product's like, it's a bit annoying. But again, it's not a huge loss. Whilst production, we're very much looking at trying to speed that up. The infrastructure has changed very much over the years. For example, in the 1980s, we got Apple III. We got Ethernet, networking, come to the rise, and we got the classic Windows 95. You know, everyone has their kind of golden operating system. Windows 95 is right up there for me. And again, you've got the sake of the first modem was used in 1996. And then we start to progress. We then start to change. We then start to be able to manage attributes, objects, and all sorts. With the likes of technologies of Active Directory, we're now supplying updates to our operating systems using Windows Update per se. Technologies really, really change dramatically each decade. And then it's just completely accelerated when we hit the 2010s. We have the likes of Terraform, we have Azure, we have Ansible, we have Google Cloud, we have Docker, we have all sorts. Your traditional infrastructure is no longer kind of useful in a sense of putting it into a production environment, especially with the technologies that are out there. We don't want to have that approach of if it dies, it really is dead. We only know one person who can fix it. We want to avoid that. We want to try and move away from that. And this is very much where these technologies can come in. We have Terraform and Ansible, fantastic infrastructure as a code pieces of technology. And then in 2020s, we got the likes of Cloud 365. You know, this is very much a case of the pinnacle of using someone else's computer all the time. We can directly log into a machine that's hosted in Azure. That's a normal desktop, and that can be linked directly to an endpoint now. It's kind of this weird, like, thin client hybrid approach that we can take. And it's effective, because if that endpoint is destroyed, you've immediately got that instance running up in the cloud. It's very effective. The loss factor is just replacing that particular device. And again, the kind of icon at the top right there is Bicep. That's Azure's kind of new infrastructure as a code language, which allows you to spin up multiple different tenants and all sorts. Being Microsoft, they obviously wanted to release their own technology. Terraform wasn't good enough for them, but it's very much there. It's there for you to take advantage of and kind of move forward with. But this whole transition, this whole 40 decades work of work has very much kind of favoured towards the cloud. And it's not stopping. The stats are very much agreeing with this. So for the likes of Google, they're saying that 41.4% of global tech and business leaders plan to continue investing in cloud-based products, even if there is economical issues. It's a non-stopping force currently. We have Excel, Euroscape have very much rated it as $1.2 trillion kind of area and public kind of usage as from September 2022. They're not small numbers. It's a thriving business. It's something that we really need to pay attention to. And then we got G2. I've estimated that 51% of IT spending will shift to cloud solutions from traditional on-prem by 2025. But throughout all this, there's this kind of masking pattern that the majority of people's infrastructure will completely shift to cloud. But how do we manage it? How do we manage this effectively, trying to make it kind of more in tune with what we're lined up to? We don't really want to pay someone to spend many, many days going through these configurations one by one and going, I think we're good. Because that's no different to on-premise infrastructure. You know, we're still applying the same management tactics for some reason. You know, we're still taking that high-touch maintenance approach when this is, we've already gone through 4 decades worth of research and development. Why is this style of management still the same? We need to adapt, we need to change it. And this is very much where the likes of infrastructure as a code comes in. We can code out, we can map out through the likes of YAML files, Yara rules and all sorts on how exactly we want our infrastructure to look. We no longer have to sit there waiting for an ISO to burn to a disk and then to watch it install and go, great, now we've got Windows updates, I'll see you in 2 days. We can streamline it. We can make sure that it's effective. And we think back to the likes of development, pre-prod and production environments. Well, that's great. Because if ever a production environment falls and we've got infrastructure as a code, snap it back up. Point it to where you want it to run and be like, build this for me, and then we'll continue service. And that's very much the kind of goal here. And Red Hat have very much defined it as managing and provisioning of infrastructure through code as opposed to manual processes that we just keep slogging on about. We don't want to have these manual processes anymore. We want to make sure we're up and running as soon as possible. But how on earth can we use this as a process? And it's a very generic process that I can put up on there. It's going to be different depending on what product you've chosen. Some of them like to take an extra step of initialization. But first we need to, of course, create the code, which can be a really nice outline within the sake of a YAML file detailing what operating system you want, where to pull it from. So whether that's Azure, AWS, maybe you want it from the likes of Vagrant because you just want something headless, just completely spun up straight away. There's that availability there. So we need to create that code. We need to make sure the kind of foundations have been drawn up to some certain degree. Past that point, we need to plan and test it. So Terraform, we've got a great module where it's test, where you can literally type in Terraform space test, and it will plan it out for you. And it's fantastic. It will see whether it's actually going to work on AWS, Azure, whatever it is your target is. And then as soon as you're ready, you can execute it. There is a complete pre-check of how your infrastructure is going to work and how it's going to look, as opposed to building it and going, that's not quite right. We're not getting network traffic from A to B and we don't know why. Or this host is completely different and we have no idea why. Well, we had a different IT admin over there and they performed the installation, but it was a bit different because they do things differently. There is none of that. There is no arguing. There is no difference. It's just completely uniform, exactly how you like it. It's completely outlined to exactly how you like it. But again, we're looking to make sure that's ready to go. We want to make sure it can be deployed smoothly. Again, the biggest point I want to stress here is continuity, as the infrastructure as code used in a production environment. Then afterwards, we just want to plain old simple deploy it. We want to make sure it can go up and it's ready to use. Well, that's great. That's very much some of the technologies that's used to outline it, but we need an engine. We need something to drive it. And that's going to be down to the likes of something called a provisioner. So if ever you've had the joy of playing with infrastructure as code and not using a provisioner with it, it's kind of like buying a really nice car and then not having suddenly any roads to drive it on. It's useless. It's absolutely useless. So with this in mind, it's a case of you need to make sure that you've decided your provisioner. I would argue first, how do you want this code to be point and shot at? Is it a case of you want it gone to the likes of a local instance of ESXi, maybe Proxmox? Is it something more on-prem that you want to make utilization of in this fashion? Or are we doing it to the likes of traditional cloud services like AWS and Azure? Either or is absolutely fine. Just need to decide how that's going to be pushed through. So for example, we got Vagrant up at the top, which is a great provisioner to be able to push through to local hosts. So if you've got VirtualBox and you want to play around with infrastructure as code, you can deploy multiple Kali instances, you can deploy fantastic kind of environments just to have a little play around with what's currently available. And then Terraform being one of the primary provisioners that's used across multiple different parties. Its libraries are fantastic, it's vast, and its adaptability is great, and it also has a health checking function as well. So if ever your infrastructure changes, you can get it to set up so it notifies you, and it will automatically correct itself if you configured it properly as well. That's resilience as well as continuity, kind of all under one hood. It's a fantastic way to move forward with it all. But then you have the likes of configuration management. So we provisioned it. We can say, spin up 3 Windows servers, 2 Linux servers over there. Great. Well, then we'll do that. But now what? Well, we want to do a little bit more kind of finite configuration management. Well, using the provisioner, we can configure. But if you want to go even more sophisticated, this is when you start pairing up technologies. So Terraform and Ansible, I don't know why they're looked as opposing technologies, because they work really, really well in harmony. If you have Terraform to provision your Windows host, your Linux host, and you go, Ansible, here's a playbook that we've used and we know it works, go ahead and run it. Build it for me straight away, because you can get Terraform to call Ansible straight away and continue forward. And the great thing, again, with Ansible is it's idempotent. So if it needs to make a change, it'll make a change. Otherwise, it won't. And then it'll recap you at the end to say what's been changed and what hasn't, which is awesome. All right. If you create that baseline, if you always want to be re-hitting that baseline, then there's nothing more that we can ask for, and it's agentless. So I was sick and tired of installing software where you have to try and get either whatever they want to call them, sidecars, agents, whatever the label might be. You don't have to go through that process of trying to install it on multiple different hosts and to try and make sure everything's communicating well. It communicates over SSH. Can it log in? And if it's the likes of Windows, it looks for WinRM, that rote management kind of service line. If it can communicate on both of those, you're good to go. You can install whatever you like and then configure it incredibly quickly. But the 2 key files of Ansible that we need to be aware of is your playbooks, which is the YAML files that will outline exactly how your operating system will look, and your inventory. It needs to know where to point to. But again, looking back to your provisioner is ultimately your inventory. So you can say to Terraform, create me a file of all the IP addresses and categories of what's being created. And you just push that through to Ansible. Cool, we have our section web. We have 4 web servers here. Okay, Ansible, for only web, can you make sure patches have been applied to Nginx? It's a really smooth kind of transition forward approach to infrastructure. We're kind of applying a CI/CD pipeline, but to production environments, which is very much the kind of goal of this talk anyway. So this is very much what a very basic Ansible kind of YAML file will look like. So what we said is we've gone provision Kali Linux and install tools. And the tools have been put into a particular list that I've put into a provisioner configuration, which I'll show you in 2 moments. And then it's the case of we want you to apply updates and then go systematically again through that tool list to make sure everything's installed correctly. That's it. That's the whole file. Just in case you think that I've cut it short, that is the entirety of the file. Just to spin up Kali Linux on a local machine using VirtualBox through the likes of Vagrant. And we have Vagrant here. Just listing out the tools to install. As you can see, we want to make sure that CrapMap exec is installed, Sliver, ArpScan, Covenant C2, and Metasploit Framework. Nice and simple. As you can see, it's config.vm provision. We've just pointed it straight to Ansible. Deployed on machine, Ansible, you do the rest of the work. It's a really nice and effective way to deploy that particular infrastructure. But not all teams are equipped to deal with the CLI fashion, that command line interface approach. But there is Ansible Tower, which is kind of going to become more of the key part of this talk. Essentially managed, you can create users, you can create organizations, and you can make sure that everything is smoothly locked down to whatever provisioner or cloud service you want. If you've got a huge team, massively beneficial. If you've got a team of under 10, I would say it's not worth it. But from the management perspective of what needs to be run to check in the status of these jobs, you're not constantly having to look at the processes on your machine and see what's been run and what hasn't. You can just simply go into jobs or projects and just see what's being run, where from, and what files have been used. So we've got a little glimpse of Ansible Tower here, where it's going to be logged in and it's going to look at the likes of your inventory, which is a really key part of Ansible. Because remember, this is the part where we're going to point it to the relevant areas and the hosts that it can touch. That's really nice and simple. We can very much add in hosts, we can specify variables and so on. And then immediately we've got our inventory there to call upon for projects. And that's no different to when we're looking at projects. We can quickly add one and detail it through exactly what we want to call it, what inventory it's going to call upon, and what actions it's going to take next. But it's not just local access that we can configure. Like in this one, we've configured it to point to GitHub. So if you've got your code management using the likes of GitLab or GitHub, whichever way you kind of got about that, you can point Ansible Tower directly to it, and it can pull collaboratively down to then run these environments. It's a really nice way to go about it. But of course, with every product, there's the faults. There are bound to be issues, and we need to make sure we can address them. We need to make sure that this is not going to be something that you're subject to, especially considering for the whole talk I've spoken about using this in production environment. I don't want anyone to go away and be like, cool, downloaded it, we've been compromised. Like, no, that's not what I'm here for at all. But the three key things that I've very much found with Ansible Tower is the API abuse. So this is an authenticated attack. It's not something that can be done authenticated. So you will need to already have a valid user account compromised to be able to complete this. But as you're going through the creation of organizations within Ansible Tower, you can upgrade a particular user and you can make sure that this user has super user rights. And as you can see, the part kind of highlighted, it's a JSON request in it using the post method, and it's just a simple variable of true. If you modify that, there is no server-side validation, and it will continue through creating that account. You've suddenly upgraded an account from what could be a standard user to super user rights, where you can create as many projects, playbooks, change inventories. You can cause a lot of damage. You could even spin up brand new infrastructure if you wanted to, which is the part that really interests me. All right, just suddenly spin up anything, kind of going everywhere. What if you're coming from an unauthenticated perspective? Well, unfortunately, it's not as interesting. But what you can do is that you can connect over the likes of the WebSocket service line and perform information disclosure. So here we've got a request going out to Ansible Tower over WebSocket, and on the response, we can see what jobs are running. Don't see any other details, so that's about as interesting as it gets, unfortunately, with this attack. But we can see what jobs are running. We can see that it's got a project ID of 56 and it's pending. Okay. We can kind of determine the value of that particular Ansible Tower service, depending on how many jobs are running potentially. But that's about as far as it goes in this one. But it's just something to consider. We were trying to keep information disclosed to, obviously, a minimum. Then we have the likes of Ansible Playbook misconfiguration. So when you're installing Ansible Tower, they tend to point you to the usage of Docker, or, of course, using Ansible to try and deploy their own product, which is great and all, but the default settings within their own inventory file is quite ridiculous. So you got a case of you have the host names, you've got the credentials, which is the far more interesting part, because it has Postgres SQL database, which you can have direct connectivity to, and it's just kept with those credentials. Unless you actually go in and change them, you'll quite often find default deployment will keep those credentials. As you're saying with their web portal, it's admin. And that is very much kept by default. For something that's, as we discussed earlier, is 4 decades worth of work, and they kind of stuck with default credentials, it's something that just needs to be addressed and needs to be fixed. But the bit that I found quite interesting is, what if we found Ansible on a compromised host that can communicate back with Ansible Tower? So, for example, let's say we had a misconfiguration with sudo rights, and a standard user was able to run an Ansible playbook due to a service designated by Ansible Tower. Is there something that we can do with it? Yeah, absolutely. We can go ahead and create a playbook to abuse that API that we were talking about earlier. We can go back and create a user with the default credentials that we've identified in the inventory files that are all over GitHub. There's 35 plus releases on their official AWX GitHub. And we can pull these credentials down and use them potentially. where we can. If they've been good enough to change the default credentials, then this won't work. But it's something to keep in your back pocket to see if you can have that for the future. But ultimately, how do we resolve these issues? Unfortunately, it's that classic thing of apply updates where possible. Like, even though you have Ansible Tower, which is now renamed to Automation Platform by Red Hat, that's a paid product, whilst you have their upstream community one called AWX, which is what the clips that you saw of earlier. It's AWX. Still absolutely fantastic, but it just doesn't have that extended support that you might receive with the automation platform. Again, change default credentials. Ensure the user rights have been configured correctly when you're deploying your playbooks, when you're deploying your infrastructure, and ensure that the API calls are coming from an approved location. If there isn't a direct patch for it, it's a great mitigation to make sure that it's coming from the correct location when kind of moving forward. That's very much how infrastructure has progressed over the years. A nice glimpse into Ansible Tower and some of the key issues that I found when researching it. So thank you very much. Is there any questions at all? Go for it. The only times that I run into issues when trying to run updates over fleets is when the inventory files haven't been updated at the same time. So if it's a case of the actual back-end networking hasn't been configured through like the infrastructure as code, and let's say it's using a DHCP service, but a couple of hosts have dropped down, they got a new IP address, sometimes you can't find it. So the best way that I would kind of go about that is to create a designated sole DNS server and translate that to hostname, and then keep the host names in the inventory file whilst pointing at the new DNS server. That might stop the issue. But yeah, it's an interesting question. Go for it.
When you provision a Windows machine, how do you start the licensing?
With the actual licensing, that's going to be a separate playbook to kind of go around, because you have to use Chocolatey Package Manager to actually configure Windows entirely. So yeah, it's going to be a bit more of a workaround to get the licensing correct. Otherwise, when using development environments, you've got Windows development ISOs where they don't have the timeout for the trial. So your best bet is to start with that and then move forward.
Can it control privilege levels?
Yes, it can directly create AD and control kind of AD in multiple different fashions. All right. Keep an eye on the GitHub. I'm going to be deploying a Ansible file and Vagrant file where you can spin it up and you can have a little play with Ansible Tower, along with a bit of a CTF that I've made around Rivesk with Ansible. And thank you very much for your time.